Hi, my name is Marco from LightObject. Today our topic is the bin alignment. As you may know, a good bin alignment is the most fundamental and significant that affect the overall performance of laser machine. So before I start to show you guys how to do the calibration, let me show you how a laser machine constructed. In general, a laser tube is setting at the back of the laser machine, and this is the high voltage size. You can see that there's a coil. The coil size always the high voltage end, and by looking at this end, this is the first mirror, and we have beam combiner here. So the laser shoot the beam to the first mirror and get 90-degree deflect to the beam combiner and going to the second mirror. Okay, by looking at different angle, that is the first mirror, and it is stable and fixed on the chassis. So the beam hit the first mirror and travel 90-degree to the second mirror. The second mirror is not stable. It is traveling along with the y-axis, see like this. All right. And then after the beam touch the second mirror, it make another 90-degree to the third mirror. This is the second mirror. All right. So you make 90-degree bounce from here and hit the laser head. On the top of the laser head, there's the third mirror right here. And then the beam will bounce reflect from the top to the focus lens. The focus lens is located right here in the chamber, and then it will come up to the laser tip right here. So the first thing that we need to do is to line up the laser tube, trying your best to make it hitting like 90-degree to actually not 90-degree, but 45-degree. When the beam hit it to here, there's a 90-degree bounce, right? So your first thing to do is to make sure the beam hit the center of the hole here. And then when you hit the center to the hole of this mounting plate, it will be center. It will be dead center on the mirror also. So it depends your mirror mount. Some of the mirror mount, they don't have this mounting place for putting a post right here. So this is how we do it. We kind of press it down, make a mark of the circle, and then we fire a laser. See how center of the laser beam hit it to the post. And we need to make sure this must be dead center before we do anything else. This is the mirror mount. For the first mirror and the second mirror, the structure, the design are pretty much the same. If you look at the design, you will find that there's a 3 screw over here. Each one will play a special role to the beam deflection. This one, it will make the beam going left to right. So if you look at the beam like this, when I twist clockwise, the beam will go in this. When I twist the other way, it will go the other way. And this one is making the beam going diagonal. So if I twist clockwise, it will bounce up. And then when I twist counterclockwise, it will bounce down in close to 45 degrees. And this one will going up and down. So by combination of these 3 knots, you can control the beam to any position you like. However, before we doing any beam alignment, I would suggest you guys to get a piece of paper, get a pen, and draw a simple diagram of the mirror mount and write down, and draw down the screw. And then you put a mark yourself, put a marking. Like for example, when I turning clockwise, I want to note the beam, how the beam deflect. Let's say when I turning clockwise, it's going to up, right? So I'm going to put an arrow up. And then for this one, if I make a clockwise, the beam will going up. Same thing to the last one. When I'm making a clockwise turn, it's going to be going down or up. It depends the structure of the mirror mount, all right? Because we have a 3 screw here. If you don't write it down on a piece of note, it's really confused. It's hard for you to do the adjustment. This is very handy, all right? Okay, I'm going to use a small version XY gantry to demonstrate the beam alignment. First thing to do is we get a Post-it, those sticky paper. So we put it on the second, assuming you already did the alignment for the first mirror, right on the center, right? So let's go do the alignment from the first mirror to the second mirror. So what we did is we put a Post-it right here, and then press it down to make a marking so you can tell the laser intake hole, and then we can see where is the center is. So after that, then we set the DSP controller card, the laser controller card, to low power, low enough not to cause a big burn or firing on a piece of paper. Usually we use 8%, 7 to 9%. It depends your setting, depend on your power supply, the laser tube. So it's hard to tell what exactly, but here what we use is 8% in general. Okay, so I'm going to press fire the short, quick and short. So, if the laser will fire the laser beam to the Post-it, we need to make sure this one will hit to the center. Boom. Right? Assuming this is the center, then we move the gantry to the far side. All right. Then we fire another laser, and our goal is to make sure the dot you see over here match this dot over there, the second burn. All right. So let's say we fire the laser, and the beam is going out right here. So it's not going to work. You know the beam is off, right? So how do we do it? Remember, I told you guys, looking at the drawing, and then twist the 3 knots, bring the beam, the red dot to the center. This one, if you look at the structure, it's pretty much the same, but they just have different direction, different angle. It doesn't matter because it adds the same way though. All right. So we're going to twist the 3 screw right here and bring the red dot, the second dot, to the center. All right. So we are going to twist it, assuming I'm twisting, right? So bring the dot to the center. Boom. Now it match, right? Once it match, it's not done yet. So we are going to move the gantry back to the original position, and then fire another shot. Boom. Then we want to see if the third firing, the shot will again match the same dot right here to the center. If it's not, that means there's something wrong. We have to redo it. In that manner, it's not just the 3 screw can contribute the correction. You must do some adjustment on the mounting plate, and which is a little bit advantage to do it. All right. If you can manage to get this one done by following my procedure, you can do it the same way to the second mirror, to the laser head over here. This is the same procedure. Okay. Now let me show you what's the possibility that you will get the beam not matching over here and how to fix it. Okay. Let's get another Post-it. Again, we fire one shot and it hits the center. Boom. Assuming the center. All right. And then we move it out. And we hit again off. It show the offset. Then we twist it, and then when you twist it, you bring the pin to the center right here, which is good. Now you bring the gantry back to over here, and then you fire the shot. However, this time it doesn't match. You're going down to you bring the laser beam to somewhere else. Like for example, over here, it's not in the center, but close to the bottom left. So what did it tell you? It tell you that this place you have to change the how to say 3 screw. You need to bring this mountain to the mirror in different location. If this is close to the left, now to the bottom left, that means this one is too far. So you need to turn the 3 knots together. What we do is I will put a marking over here, the 3 dots, and then I'm going to change, let's say 3 rounds clockwise, 3 rounds clockwise, and 3 rounds clockwise. On 3 of those, we'll bring the beam to different center. The reason is when you see the beam getting close to this bottom left, because the whole mirror, it's not the angle, but the whole mirror is too close to the left side. So we need to bring the mirror out. So the only thing to do is you have to bring the mirror mount outward in parallel way. I mean, all the same distance for each knot. Okay, I'm going to show you another example that the beam couldn't match at all. All right. So first of all, we put a note right here. We press it down again, get the marking, so you can see the circle clearly. All right. Now we fire a laser shot and make sure it hit to the center. Let me see, try to be smooth. Assuming this is center, okay? So, and then we move the gantry all the way up over here, and then we fire another shot. And assuming the dot is right here again to the top right, boom. All right. And in that manner, we are going to adjust the 3 screw knot over here. Try to make the dots on this particular position to match the first dot. So we are going to twist these 3 knots. Again, you need to get the cheat sheets that I told you to do in the beginning. This is very confusing, and you got to have this thing done. All right. So I'm going to bring the dots down like a diagonal from the top right to the bottom left to the center, right? And which one? Let's say this one. I'm trying to match the configuration. This one, by doing clockwise, it will bring it down. So I'm going to turn it clockwise. Boom, 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 boom. Now, assuming the dot now is hitting to the center, right here. Boom. It matched pretty good. All right. So is it done yet? No, actually it's not. So you need to bring the gantry back to the original position, closer to the first mirror, and fire another shot, and then see how it goes. And then when we fire the shot, and then the shot, the burn mark didn't match to the center. Instead, it's going all to right here. What did that tell you? Well, in this case, a little bit complicated because the beam is not like this. In the beginning, the beam, we know that it's going this way, right? Going upward to the right. But in this particular case, the beam actually curves. So it's going this way. So how do we fix it? Well, some people say, hey, let me keep tuning the 3 knot, try to fix the issue. And I can tell you that this is not the case. No matter how you tune this 3 knot, it's not going to fix the problem. The problem is this mount is too close to the gantry. So here's what I'm going to do. I'm going to tune this knot again. But before I'm doing so, I need to move the gantry to the far. And then remember, at this position, when you fire the laser dot, it will hit the center, right? So, but I don't want to do it. Instead, I want to twist these 3 knots. Make sure the dot, when I fire, it will hit the same burning mark over here. Why do I want to do it? Because I want to make sure the bead is going straight. All right. Now, assuming after tuning these 3 knots, I got a bead straight from here to the far side, and they're going straight. When I bring it back to here, when I fire the laser, it will hit the same dot again. All right. So that means the bead now is kind of straight, very straight, but they are off. They're getting too close to the mirror. So how do we fix this problem? All right. Simple. But I want to show, there's 2 ways to do it. Either you move, let me see, get a bigger, first mirror mount for the demo. All right. Either we move the whole mirror out, or we do the 3 knots here. I want to tell you, you don't want, in general, you don't want to mess around with this place. You don't want to move the location, because once you did that, it's really hard to fix it, to correct the angle. It takes quite a long time to do it. So I would suggest to do on these 3 knots. Then you told me before, we can fix this issue by making the tuning these 3 knots. Well, that's another case. All right. So I'm going to show you how to do it. Assuming you already got some space over here, and you are not, the mirror mount is not too far away from the laser head. The mount over here, there's still room to go. So how do we do it? That's one way I used to do it. I put a marking right here, like 12 o'clock, and 12 o'clock over here. I can't do it over here because it's too small, right? So my goal is to move. Okay. This I just want to let you guys know this structure is a little bit different, but I'm using this one for example. This place, the mirror mount is too left, so we need to bring it to the right instead of moving the whole mounting module. This is the way I'm going to do it. We put a marking right here, and then we let go. Let's say counterclockwise. 1, 2. All right. Then I do the same thing to here. 1 and 2. And again, the third one. 1 and 2. What it is, the mounting plates for the first mirror will shift, how is it? I would say parallel to the laser tube to the right. Right now, after you do it, when you fire the laser dot is going to, let me get more. The laser dot is going to move from these dots now to this close to the center. And then we move the gantry farther away. Boom. And fire the shot, you will see that the laser will pretty much match to the first shot over here. Once this is right, once you confirm this is right, then you lock up the screw right here. There's a 3 screw. You want to lock it up slowly. And you want to do little by little, not, and you need to do one on each side, one little bit over here and then a little bit over here. And then you use a plier to lock it, but with some care, all right? So you want to hold the knot over here. You want to hold the bolt here and turn the nuts, lock it up. And after done, then you use a hex screw and lock up these two screws. So the mirror mount won't move during transportation or during high-speed engraving. I have already shown you how to do the calibration, the pin alignment from the first mirror to the second mirror. And you can use the same procedure applied to the second mirror to the third mirror. The procedure is identical. So you just need to manage from the first mirror to second mirror, get yourself familiar with the knot, how it reacts to the pin. And the next part on next video, I'm going to show you to do pin alignment from the third mirror to the focus length. And a lot of you may think this is simple, right? Because the distance is pretty short. It should be easy to do it, but I'm telling the truth, this is not, and this is most difficult and most significant. And I will share with you guys on part 2. All right. Thank you for watching.